Hello, everyone. You are welcome to today's meeting. In today's meeting, we are going to have a very short one. And our duty is to look at what the solution to the assignment that was given in the previous lesson, the lesson on rational functions and partial fraction. And as you can see on your screen, this, was the assignment. So quickly, let's go and look at the solution. I'm going to walk you through the solution. Okay, and I will take care of all the concerns that came to bear whilst marking your submissions, what you sent to me. So as usual, okay, so this was a question here. Okay, you check anytime you read question, check whether there is any salient part for you to underline. Okay, so on this note, okay, this is what we are supposed to do. So you read a question, okay, and obviously we are asked to resolve into partial fraction. So if you like, you can underline, okay, resolve. So meaning indirectly, it's not necessary to underline resolve. Okay, then you come and write solution. That is the first thing that you write after you have underlined the salient part. But I said here, there is no salient part for you because usually when you are dealing with partial fraction, you resolve. Okay, so take note of that. Okay, so at this point, okay, now we've written solution after solution. Okay, questions are numbered because we want you to also number your solution. So the next thing that you write is the question number. There is no major question number, but there is a minor question number A. So A, then you extract what you are giving. So giving this, or you can ignore the giving, but you cannot ignore writing this. Okay, so remember, the very first question you need to ask yourself whenever you are dealing with a partial fraction resolution. Okay, you know, first of all, you have to write the identity before, okay, you get the values of what the letters you introduce in the identity, you substitute, and that will complete your resolution. So the first question, proper or improper, and obviously this is what proper. Degree of the numerator is 0, that of the denominator will be 3. 2 for this factor, 1 for this factor. So if you add, you are going to get 3. And if you expand, you get s cubed as the highest power of your variable, so making the degree 3. So now we know it's proper. When it is proper, please take note. The next thing that you concentrate on will be the denominator. Okay, so your denominator, you check the factors that you have there. Is any of them factorable? If any of them is factorable, then you factorize into the distinct factors before you start to write the identity. However, I can see that this is a quadratic factor, but you don't have to see it as a quadratic factor. I will explain why. And this is a linear factor. Okay, now this is a special quadratic factor. There is no x term, because for all quadratic expression, okay, when written out completely, this will be the nature of what? Of your expression. Usually we say that quadratic expressions are of the form ax squared plus bx plus c. There is a vital condition that you need to attach, a not equal to 0. Other than that, it's easy to be quadratic. So take note, this is a special quadratic, okay, where your a is 1, okay, your b is 0, and your c is also 0. Okay, so there is only one quadratic term. Okay, however, that quadratic term that you have there, the coefficient is what? Is 1. Even if the coefficient was 2, okay, or let me restrict myself to what I'm saying. Later, I'll bring in that. Okay, so when you have this is a special situation, and you can see that though you see x squared to be quadratic, but what you have here indirectly is a repeated linear. Because I have a quantity with a power. And I've told you, anytime you have a quantity with a power, first of all, look at that quantity to be a repeated quantity. Then the power will determine the number of times your quantity is repeated. So some of you saw this to be, what do you call it, quadratic, and you realize that if this is quadratic, this is linear, so you get 2 fractions. The first fraction, okay, you are going to get, because the denominator is quadratic, the numerator will be as plus b. Okay, then this one will be linear, numerator will be constant. You did C over that. Immediately you do that, you are wrong. So my questions are carefully selected to take care of all the tricky situations. Okay, the major knots that usually, okay, you are not able to untie and that will be very costly. So in this case, now if my point is well made, this is x. Okay, so if I had maybe x plus 1, or let's say s squared plus 1, the whole of this squared, okay, then I can treat this as what? As a quadratic factor. But this is a linear factor which is repeated because of the power. So you take note of that. Okay, so it means if it was cube as well, you would have treated this as what? A repeated, okay, linear factor of x, but repeated 3 times. Is my point well made, my professors?
Yes,
sir.
Okay, so very good. So at this point, okay, the rest I'll run you through. Okay, so in this case, what are we going to do? We know because okay, this is repeated linear. We know that the power would tell us that this will give us 2 fractions and this will give us 1. So in all, we are going to get 3. So your first fraction now you can write the identity because none of them is factorable. So it will be your first fraction. The denominator will be s. The numerator will be a constant because it's linear. Again, your repeated denominator s squared, numerator is the repeated factor is linear, so it will be b. Okay, then it's a constant. Then this is linear, its numerator will be a constant, so you take notes. So a, b, c. Okay, after your first identity, which you shouldn't, at the point that you introduce your letters, that's where your identity sign should be. Please don't use the equal to. So this is identical to this. So in actual fact, this is the partial fraction identity. Now we are going to resolve by finding the values of a, b, and c and going to substitute. So now what do? We know the next step is to take the LCM. So that will be equal to. If you take the LCM, I've told you without struggle, okay, your factors here will be your denominator. So you ask yourself, x will go into your LCM, your denominator here, which is s squared into x minus 1, how many times? And you can see that if you divide s squared into x minus 1, okay, by x, the x will cancel one of the x here. So you'll be left with x into x minus 1. So it will be a times x into x minus 1, which will give us this. Okay, I did the same for this. S squared will go into this. The s squared will cancel. You'll be left with this. So it will be b times this. Then again, you come and do x minus 1 will go into this. How many times? S minus 1 will cancel. So you'll be left with s squared. So it will be c times s squared. Okay, so at this point, remember, since the denominators are the same, we equate the numerators, and that will give us what we have here. So here, you realize that your factors that we have here, we were dealing with linear. One of them repeated though, but we were dealing with linear factors. So here we have x is equal to 1, a linear factor, then x. Okay, another linear factor. So that will guide us as to our choice for the x for the substitution. So here I want to use the x minus 1. Okay, so I equate this one to 0, cover up, so that will give me s is equal to 1. So if s is equal to 1, okay, I come and substitute. I will get 2 is equal to wherever I see x here, I substitute 1 here, and that's exactly what is here. Okay, then after that, you go and simplify. So your next step, you are going to get 2 is equal to, you know this will give you 0. Any term that contains the factor that you set to 0 to find your x will vanish. So this term contains what? That factor. Okay, so this will be 0. This will vanish. This also contains that factor. It will vanish. So I will get 1 squared, which is 1 times c. So I will get c here. So in effect, I know the value of c. Okay, I need 2 more, b and c. Okay, so b and a, forgive me. So now what do we go? The other linear factor was x. So you equate that one to 0 and you get x equal to 0. So that one you substitute x equal to 0. The same explanation. Okay, if you come and simplify, this will give you 2 is equal to any term here which contains the factor that you set to 0, which is your x. Okay, will give you 0. Okay, so this one will go. Okay, this one doesn't contain. So this will give you 0 minus 1 will give you minus 1 times b. So I will get minus b. But this will also give you 0 squared, which is 0 times what? C, which is 0. So that will go. So in effect, you have 2 is equal to minus b. So it means b is equal to minus 2. Some of you will divide by negative 1, but it's not necessary. You can move to the side, or you can just write it this way. In effect, it's like you move this one, and you've made it positive. I guess my point is well made, my professors.
yes, sir.
Okay, so now we know the values of B and C, so we are left with A. So at this point, we've exhausted all the possible linear factors. Okay, 0, then 1. So we have to go and settle on our liberty values. Okay, any of them. Remember, we've used 0, you've used 1. Okay, somebody can go and use -1, but I said, okay, move positively or positive wise. Okay, so in this case, we are going to use x is equal to 2. You can use any other value, take note, just as I mentioned. So if you substitute, this is what we are going to get. You substitute that one into, okay, this relation here. So at this point, we are going to get 2 will be equal to, so I'm going to simplify. This will give me, I deal with what I have in bracket here. 2 minus 1 is 1. Okay, times 2, that will give me 2 times a, so that will give me 2a. If I come here, I'll get 2 minus 1 is 1 times b, that will give me b. Here, I will get 2 squared, which is 4 times c, so 4c. So at this point, because I know the values of what? Of b and c, I can substitute and go and find my a. So that's what I did here. This implies that 2 is equal to 2a minus, okay, 2, because it will be plus minus 2, b is minus 2. So instead of writing plus minus 2, we know we are matured. We know that it will give us minus 2. Then plus 4 into c, c is 2. Okay, at this point, we come and simplify. So you move the bracket here. If you combine this side will give you, I combined and moved, okay, mentally. So this will give you positive 6. You move it to this side, you are going to get negative 6 plus 2, which will give you negative 4 is equal to 2a. You write it again before you divide. A will be equal to minus 2. So at this point, this is where, okay, some of you concluded the way I advise you shouldn't. Okay, remember, you always avoid concluding with a negative term if there is at least one positive term in your expression. And please let this be the last time I'm saying this. So here, at normal circumstance, you are going to draw your conclusion for whatever you are given here is equal to. So you come and substitute the value. So A is negative. I can't start with A. What about B? Okay, B is also negative, so I can't start with B as well. Okay, so let me see the next one. Okay, C is positive, so I can start with the C. So that informed that decision. So I write 2 over x minus because C is 2. Then now I can come and start with any of the 2, but I want to move in this direction. Okay, I shelve this one first, followed by this, but the other doesn't really matter though. So A will be equal to minus 2. So it will be, you don't write plus minus 2 over, you are matured. You know that it will be plus, the minus 2 minus will overpower the plus. So you get this, and again, same for what you have, and this becomes the solution to the question A. Point well made. Any questions before we move on to that of the B? Are we all fine?
Yes, sir.
Okay, great. Okay, so I guess all concerns well, okay, taken care of. So now let's move on to the B. Okay, all right. Some of you, though, I didn't teach you a particular way of dealing with this. Okay, because you ask yourself that vital question, you realize that, okay, the rational function that you have here did not suit the usual one. Okay, so you were trying to maneuver your way around or find your way out. Okay, you did quite well. However, remember, I told you, first of all, let's ask ourselves that vital question before I will say whatever advice I gave you in our previous meeting that I realized I did not adhere to. Okay, so what we have here, degree of the numerator is 2. Degree of the denominator is also 2. So it means what we have here is what? Improper. Okay, so if you have improper and you want to go the identity approach, write it, okay, as an identity before you go and, okay, find the values that you introduce in your identity. Okay, before, okay, you do that, I have to teach you a particular way. You cannot form your identity straight away like that. Okay, so here, my point is, I advise you, anytime you are dealing with a rational function, okay, and you realize that your denominator contains only a factor which is repeated. A factor, be it linear, be it quadratic, be it what have you. Okay, but most especially linear, which is what? Repeated, with no other factor attached to it. Always go for the substitution method. It will be ideal. So I am equally going to heed that advice. Some of you, okay, you use that, but along the line, your algebra exposed you. That was the issue. Okay, so here you don't know how to deal with improper, but you know if I have repeated a factor in the denominator, I am too good to go by using substitution. So let's go. Let u be equal to s plus 2. That is your factor that is repeated. Now you know you substitute for x. Okay, so in that case, x will be equal to u minus what? 2. Okay, so at this point, I said either you write implication here or you come and write therefore. Okay, and we are mature, so we can write therefore here. So therefore, what you are asked to resolve, okay, here will be equal to. Now, what do? Your x here, you said is what? U minus 2. So it will be u minus 2 is a binomial u square, then plus 1, all over what? Your s plus 2, you said is u. You represented that by u, so u squared. So you've changed from x to what? U, just for convenience sake. Okay, so at this point, okay, some of you, this is where your problem started. Okay, so if you are squaring this, you know you've been taught how to expand any binomial squared. So if you have a plus b all squared, you should know what this expands into. If you have a minus b all squared, you should know as well at this level. So we know that this, if you expand, will give us a squared plus 2ab then plus b squared. You should know this identity, just as you should also know this identity. A squared minus 2ab plus b squared. Okay, otherwise, then you are supposed to come and take what u minus 2 multiplying, okay, that squared means multiplying itself again. Come and expand, combine your like terms before you move to the side, or you do the expansion combination of like terms, which will waste your time. So here, maturely, we know that our a is u, our b is what? 2. So if you expand, you get a squared, which will give you u squared. Then if this is minus, between your first and your second term, okay, it will be minus twice the product of this and this, which is your a and b. So the product of this is 2u. Twice that will give you 4u, so minus 4u. Then plus your 2 squared, which will give you 4. Then plus your 1. Is my point well made here? Especially those who got this, okay, wrong, the expansion wrong. You shouldn't get it wrong, because you can always, okay, use this to verify your usual way. So at this point, what do? We have seen that the numerator we have, after removing the bracket here, there is like term to combine. So we combine that, then because what we have here is a single fraction, remember we are leaving that our answer must be left as a partial fraction. So it will be each one over the denominator, each of the terms in the numerator over the denominator. You come and simplify, then you go and substitute. So this will be, okay, the simple way. So those of you who knew how to deal with what the improper way, okay, rational function way of resolution, okay, you realize that this will be ideal. That one you write more. So always take note. Every special, okay, question indirectly, okay, will have a special way of dealing with it. Every special situation demands a special way of dealing with it. So you should know how to recognize the special and how to use the ideal way in dealing with what the special situations. Okay, so on that note, any questions before I bring the curtains down on the solution to the assignment? Okay, we'll look at the other way, the improper, the identity way, how to deal with that. We'll do that, and that is going to be our main lesson for today. But because you've not been taught that and you have another way, which is the ideal way, you do it. So even if you know that or you knew that, okay, I will advise you don't use that approach. So we'll handle this question, okay, using that approach going forward. Point well made.
Yes, sir.
Yes, sir.
Okay, so is this question that will usher us into the improper fraction, okay, situation. Okay, so on this note, thank you very much for making, okay, the class, okay, a success.